Hi, I'm Geoff from Ethereum Foundation's Privacy and Scaling Explorations team. I'm helping out with an Ethereum project, the KZG Trusted Setup Ceremony. If you've been following on the roadmap for Ethereum, you'll be familiar with EIP 4844. That's proto-dank charting and data availability sampling for rollups, and that's all driven by KZG polynomial commitments, and those polynomial commitments need a trusted setup. So what we want to do as a community is get everyone contributing to this trusted setup. Now, once upon a time, I learned that Koreans don't say once upon a time. They say back in the days when tigers smoked long pipes. Sounds like a great time to be around. So anyhow, back in those days, trusted setups were a pretty complicated, difficult sort of thing with lots of complicated interactions between the participants. But these days, the protocol's quite a bit simpler, and the other things we have going for us in this situation is we don't have a zero knowledge trusted setup. It's just it's a polynomial commitment trusted setup, and it's only for a relatively small number of points, like 2 to the 16 or 2 to the 15 is our largest sub-ceremony. So it's like much smaller than if you've contributed to trusted setups before. This is quite a bit smaller than those. So it's going to be nice and easy for people to contribute to. It'll be a fairly quick computation. Maybe the actual computation should be a few seconds, maybe 10 seconds or something, and then less than a minute to upload and download and do the computation. So everyone is going to find it really easy to do. It's going to run in a browser, be quick sign-on protocol, and then just let it run. So nice and easy for everyone to do. We need to get each contributor we can only have one at a time, and there'll be a coordinator collecting these contributions and then figuring out who to pass it on to, and so it's one at a time. The contribution is passed along around the participants. And the security properties are that if we get one person who successfully discards the secret that they put into this computation, then it's going to be secure. So just an analogy to understand how that works. If you have a private key and you do the elliptic curve multiplication and you end up with a public key, and if you pass your public key to me and I mix it with my private key, we end up with a new public key. And if I then throw away my private key, then we can't derive that new public key again. So we'd need to have both those, yours and my private keys together to rederive that public key. Now, if we multiply that situation by hopefully thousands of times, then all we need is one of us to actually successfully throw away the secret that we put into that private key that we put into the computation, and then we're secure. So that's what we're aiming for. We need to defend against attacks. We need to make sure that the whole process is secure. So our main avenue for defense is to get lots and lots of participants. So we're going to make it nice and easy for people to just do the contribution, and hopefully we'll get thousands. So, if we got a chain of 1,000 contributions, all we need is one of those people to successfully hide their secret, and we're good. We will, however, think of other possible avenues of attack. If somehow the software we're using is compromised, then we need to think that someone might be siphoning off all those secrets. So we need to defend against that. So what we're going to do is have lots of variations in the actual software that people are using. So we're going to build APIs so people can write their own client, and we'll publish our own client so that people can just use it out of the box, or people can use the APIs to build their own. And then we get some variation in the stack that people are using to do this ceremony. And by that mechanism, we hope to get better resilience against attacks. It won't just be the actual client. The client will do like interactions with the coordinator to maintain their queue position and accept the download and do the upload. We'll also have an SDK that purely does the computation part of it. So, for anyone who's interested in building some of these components, we'd welcome all contributions, and we'll publish the APIs so you can do it fairly easily. And as well as that, we'll have security checks around each contribution to make sure each one is valid. We can check that the contribution is valid, that there's no that it's a valid sequence in the chain of contributions. You will get a fingerprint for your individual contribution as a contributor. So, and you'll be able to match that against a public record of all the contributions. So we'll make all this data public. We'll have a big dashboard that will show people contributing and a link to a permanent record of all the contributions. So you should be able to remember your signature for your contribution and look it up in the public record, and that ensures that the coordinator is not swapping in their own data and corrupting the ceremony that way. Yes, so the actual process of contribution is there'll be a simple sign-on, very simple, 3 clicks, probably sign in with your Ethereum address. Then you can join the queue at a time of your choosing. And as I said, we'll have a dashboard and it'll show how long the queue is. We're hoping that the queue will be fast-moving, but of course this is going to be quite widely publicized, and we're hoping for lots and lots of contributions. But so there could be a bit of a queue, but it should be quite fast-moving because this is a very quick contribution. So you'll join the queue. When you come to the head of the queue, you'll request the latest valid contribution from the previous contributor. You'll generate some randomness, and that's your secret that must not leave your environment. With that randomness, you'll feed it into the contribution. You'll update the data, and you'll send that back to the server. And then make sure the randomness is thrown away. So all of this, for an ordinary user, this will all be behind the scenes. You just do those couple of clicks to sign on and click a button to let it go, and then the browser will look after the rest. But if you're interested in building a client API, these are the steps you'll do. We'll have APIs for all of these things. So yeah, there's lots of ways to contribute. We want to get everyone just doing a contribution in the browser, but if you're interested in doing a hackathon project or just doing a side project on your own, we'd love your contributions. Build a client. You can build a compute engine. You could build a fancy client. It doesn't need to be a client that runs in the browser. You could run it in a CLI. You could run it in a Google Colab workbook. Just go wild with that. When we're doing the bulk contribution phase, we will have time limits. So we'll have some sort of expectations around how fast this should turn around. But we're going to have multiple stages here. So there'll be that bulk contribution stage, and then we'll go into another phase where we're a lot more tolerant about the timings, and we're just inviting like open slather on how you want to generate the randomness and compute it. And people, if someone wants to put their laptop in a Faraday cage and have a radioactive banana with a Geiger counter to generate randomness and whatever, just think of crazy ideas, and we'll have a time for you to contribute like that. The ceremony, I think, looks like we'll start in October, around the time of DevCon. Probably that bulk collection phase, I forget the timings, maybe a month or two. We just need to get this completed in plenty of time for the Shanghai upgrade, which is like sometime next year. Yeah, and there's other ways to contribute too. Like this thing will need verifiers. If you want to build your own verifier to verify people's contributions, that'd be great. Or build yourself a dashboard. So if you want to, we'll have a dashboard, but if you want to build your own, that'll be great. Yeah, so there's lots of opportunities to build things around this. And every contribution, especially in those computation phases, is going to be a really valuable bit of diversity that we can build into this ceremony. So yeah, this is really one of those upgrades that it's not just the boffins in the back rooms who are developing it. It's one that we can all be involved in some way or other. So look out for notifications about when the ceremony will start. If you want resources for the APIs, the specifications for the data format, the planning meetings, they're all on this link here. And please, you're welcome to come up and talk to me and find out more. And if we have time, then we can have some questions if anyone's got any. Or else have fun with the ceremony, and we'll look forward to your contributions. Thank you.